Hi everybody, I want to make this quick video. Been very busy. I know I haven't been doing very many videos, so I apologize for that. Quick update on the C130. I'm not sure if you can see here, but I've got all my parts printed now, so I'm putting landing gear back together. It's going in the C130. Just been working a lot. This video is going to cover a company that I'm extremely been kind of happy with and very successful with. A lot of the 3D filament I've been buying from them, and it's called 3DXtech. So the thing that I like most about them is that their website's extremely easy to understand. Picking out the filaments is very, very easy for what I've been wanting to do. So far, the printability I've been experimenting with. I've done everything from their ABS to their PETG to their carbon impregnated ABS to their nylon to the carbon fiber impregnated nylon. So I want to spend just a little bit about that, and then I'm going to go on and talk about my Fusion 360 kind of success I've had so far. So what I really want to talk about is when you buy a 3D filament, there's a lot that can go on. You know, nylons, ABS, PETGs, you can print at a little bit higher temperatures, which means in the sun they're not going to be affected as much. Here are some parts that I had done originally in PLA with another company's material. In PLA, even though it's really printable, the printability is extremely good on it. It just doesn't hold up in the sun at all, and you can actually see this, I think, where it sagged. So this should have been printed out as something a little bit tougher. So I initially had problems with nylon because nylon wanted to peel up off my heated printer bed. But I also found out that I really needed to put down, basically what I do is I take ABS and meld it in acetone, and I call up my ABS juice. So I found out if I do that right, I can get the nylon to stick. What's really nice about nylon is I think they recommend to print it like between 250 and 270, I think it is, or I think that's right on their nylon. But if you don't get good layer adhesion, if it's not sticking together, you can turn your temperature up. So what I've been doing is experimenting on how do I get the absolute best adhesion layer to layer. Because nylon is just so strong, it works for a lot of structural parts I'm building right now. And the beautiful thing about this 3D X-Tech is that it sticks to the heated bed really, really well. Okay, I've used a lot of others that I really have a hard time just getting it to stick to the bed, and so far, by far, it's been the best filament I've experimented with. Now, I'm not going to diss the other people because someone's going to go on here and say, oh, Damon, you didn't have your heated bed at the right temperature, you didn't put down the right ABS slurry or the ABS juice or whatever. But I'm just telling you right now, I have probably bought, let me count up there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, probably 12 spools of the 3DXtech stuff. And as I mentioned before, I've gotten the PETG, the ABS impregnated with carbon fiber, nylon, and nylon impregnated with carbon fiber. One thing about the carbon fibers that are really nice, even though they're not quite as strong, they tend to be more thermally compatible. What I mean by that is they don't tend to shrink as much as the regular material, especially the nylon. So when I print just regular nylon, I do get a little bit of shrinkage, and I think that's pretty typical of nylon. But when I print the nylon impregnated with carbon fiber, I haven't found any shrinkage yet at all. So I'm just ecstatic with, you know, I'm an amateur at this. By no means am I an expert, but for the beginner, you know, less than 6 months, I've put in over 1,000 hours on my printer so far. 10,000 feet of filament has gone through my Prusa printer so far. And this 3DX Tech, without a doubt, has been the easiest stuff I've used and the most predictable. I guess is the best way. So what I want to do now is I want to talk about my Fusion 360. And what I really like the most about this so far, now keep in mind I've had this less than a month. Actually, I've had it about 3 weeks. But I've already created some little folders over here. I got one for parts, and in my parts folder, I've just got some different stuff I did for testing. Like here are some different filament holders that I needed to build for my machine because I just didn't like the one that came with it. This is the unit right here I used to test and see if I can destroy parts and pieces. This was a little, basically it goes through my hot box that I run my filament through so it doesn't cut up the styrofoam. Let's see, what else do I got here? These are just all a bunch of different parts. So, you know, this just gives you an idea of the different things I'm doing. Here's the C130 parts I've made so far, and I'm actually going to open up this. And this is me playing around with a tire, the rim I'm going to try to make for the C130 using the ABS impregnated nylon. I think it's going to be strong enough, but the really nice thing about this program is just the editability, if that's a word, my ability to go in and edit things. Okay, now keep in mind I've only had this software for about 3 weeks, but if I wanted to go in right here and edit the profile of my rim, I can go in here, and right here is one side of it. This is the other half. This is like, let's say, the rear half, the front half of the rim, and here's where my brakes will go. So imagine this revolves and creates the entire rim. So that's the rim I've made. This is the landing gear block that you all, I think, seen me playing around with on my Facebook. And this is, it runs up and down. Actually, it's oriented more like, let's see, it's hard for me to do this. It's oriented like this, and it goes up and down on the tracks, and my landing gear strut runs through the middle here. I've also been very excited with the spinner I've designed in this, because I'm able to create thickness where I need it. So hang on a minute, let me show you here. Okay, so down here, as this turns, as the spinner turns, centrifugal force wants to make it explode. So I had this little lip here, and then this was all going to be carbon fiber for my 3D printer. But I just wanted to make sure that this was a little bit thicker to give me a little bit more meat here. So if you look, you can see how I have that thickness right here. But what's really cool is all of these are following the contour of the way it's going to go into my spinner backplate. So, I really, just so far have just had a fantastic time. Oh, okay, here's some parts I did for the 1919. I'm redesigning all new exhaust manifolds for the 1919. And I did all of these. So I'm going to 3D, I've already 3D printed one set of these pipes. The other pipe failed because after 10,000 feet of filament, I wore out a little spindle gear on my 3D printer after 1,000 hours of use, which I found out is a normal part to wear. And then this is the new hood for the MSL that I created. And what's really nice about this is, like, creating this air scoop here, creating all of this. They say that's a pretty high level thing to do in this program, but I got to be honest, it was not hard to figure out. It just takes hours. And here's the tracks it's going to slide in. So if anybody is scared of getting into Fusion 360, and I hope I didn't call it 3ds Max, because that's what I've been using for 12 years now. But the Fusion 360, if you've ever worked in any 3D program, I absolutely tell you, you've got to try it. You just got to absolutely try it. So essentially, that's what I want to do in this video, was talk a little bit about my experience with the 3DXtech, or 3DXtech. I always want to call it a different name. And with my Fusion 360. One last thing about the filaments. You just need to experiment with the temperatures. Okay, there's a lot out there where people say, oh, you've got to be at this temperature, you've got to be at this temperature. Unless you play with it and do some strength tests for your application. You know, when I printed out a lot of these different parts here, I tested them. Like this part here, I actually did a PETG, because the only forces on this is the motor turning. So this doesn't have to be a heavy-duty structural part. And really, I have a boatload of the PETG I wanted to test, so I wanted to use it on the non-high-strength structural parts. This was printed with the carbon fiber infused nylon. And as you can see, this little part is just strong. I mean, the 3D printed part that's that strong, I'm sure if I took 2 wrenches I could twist this apart, but by hand it's actually cutting into my hand and hurting. Same thing with this. This is carbon fiber infused nylon that I printed at 275C, which is 5C above what they recommend. But the layer bonding, now one little note, they actually say on their website that you may need to go to higher temperatures to get kind of the layer adhesion you want. So I'm not going out, I'm not saying that they're wrong by saying 270. They're saying the best settings was 250 to 270 for the filament. But for my application, I went to 275 and had fantastic bonding. Now, if this was hollow, where they built it up on the inside where it needed bridging and stuff to support it, the 275 might have been too hot and the filament would stay too melty and it wouldn't be able to work well. So keep in mind, they're talking about on their website, I believe, just the general temperatures that work. But I ran this at 275C, and this is I mean, you would never, I'm sure I could put this in a vise and twist it in half, but this thing is just, I mean, rock solid. So thanks for watching my videos. I hope you all enjoy them. I'm going to be going to Watts over Owatonna, and a big fly-in up north, about a 10-hour drive from here. Actually, about a 12-hour drive with all the pit stops and food and all that. But hopefully I'll make a video about Watts over Owatonna once I get back. And again, thanks for watching my videos. Thanks for the great emails, and have a great day.